Hello, hi, good morning everyone. So yesterday we did few questions before we did properties of determinants. So today we'll just go ahead with that only. Properties of determinants. Yesterday one property I wrote it. Okay, today we'll do the questions on that basis only. What I'm saying, just let me tell you. So today's topic is properties of determinants. Now, this property actually 5 properties I gave you a PPT, okay, but 6th property I wrote it myself. So today I have got that in a slide only. If each element of any row can be expressed as a sum of two terms, then the determinant can be expressed as a sum of two determinants. Now what it is saying, suppose this is the question. All right, now what it is, there is a plus sign in between, plus sign in between, plus sign is there in between, and it is happening in full row. So what we can do is, we can segregate it. Segregate means first element, a1 b1 c1 I am writing in one determinant, x y z I am writing in another determinant, and the other two column or other two rows will remain same in both the determinants. Repeating, if any determinant is kind like this, two elements are getting added, two elements are getting added, two elements are getting added. So we can express this in terms of like first elements a1 b1 c1 I have written as one row. Second elements x y z I have written in another determinant. Remaining two rows will be there in both the determinants. I hope my wordings are clear to everyone. Just do one thing, write till here, only the first step I am saying. Write this one first. Addition of two determinants. This is not that property, but this is one of the properties also, you can say, which I wrote. It is not that property, but it is one of the property also. Similarly, it can happen with the column also. I'll give time to write. Similarly, it can happen with the column also. Now see, plus, plus, plus. All right. So A1, A2, A3, I have written as first column of one determinant, and alpha 1, alpha 2, alpha 3, I have written as one column of another determinant, and that plus sign is there in between. Write it quickly. These things will be used. How it will be used, that we'll tell. Next, this is the proof that is not required. X, Y, Z. Proof, you guys can read it yourself. Okay. X, Y, Z, 2x plus 2a, 2y plus 2b, 2z plus 2c. We have to prove it that its answer will come out to be 0. Now there are two ways to do it. What I can do is, I can multiply first row. Rows first I can multiply with 2. Row 3 I can multiply with 2. Okay. or I can take 2 common also, no issues. This we can add and then I can subtract in row 2. There are 2 ways to do it. One way I am doing, another way also I'll do, no issues. Now see, if I'll multiply this number with 2, it will become 2x, it will become 2y, it will become 2z. So I'll write it here, 2x, 2y, 2z. If I have to multiply row 3 with 2, this will become 2a, 2b, 2c. Yes? Now what I have said, we have to add them. Add them means this will become 2x plus 2a. These two elements will become 2y plus 2b. And these two elements will become 2z plus 2c. This is just, I'm telling you what we are going to do in this question, but I'll write it. Now this element is also same. This element is also same with 2y plus 2b. This element is 2z plus 2c. So what I am doing it, here I am subtracting. So this row will become what? 0, 0, 0 it will become. And whenever any particular row or any particular column is 0, the value of the determinant will come out to be definitely 0. So answer is 0. This is the one way. So I am writing it now. Now this is 2 x only. Alright. This is x, y and z as it is. When I multiplied these two rows with 2, it was becoming 2x 2a. So this will come out to be 0, 0, 0 it was coming a, b, c. When any determinant is having any particular row or any particular column is 0, so answer will come out to be 0, or the value of the determinant will come out to be 0. Now the other way I am doing it, just now we have done one property. What we can do is, I can segregate. There is a plus sign in between, so I am segregating. This is also becoming xyz. This is 2a, 2b, 2c, a, b, c. Segregated into 2 determinants. Now what I can do is, I can take 2 common. What I will be left with? xyz, xyz and abc. Similarly, if I'll take 2 common from here, what it will become? xyz, abc, abc as it is. Yes or no? Alright. Whenever 2 rows or 2 columns are identical, the value of the determinant will come out to be 0. Yesterday we have done this property. So 2 into 0 plus 2 into 0, answer will come out to be 0. Either ways we can do. Alright. Whenever 2 rows or 2 columns are identical, as 2 rows are identical, so the value of the determinant will come out to be 0. Value of determinant will come out to be 0. Okay, this is the reason I have written. Note it down. Both ways are correct. In maths, we don't have any particular thing. No, oh yes, we have to do this solution only, then only it will be the correct one. No. Whatever the things, whatever the properties are there, anything we can apply. But yes, of course, that property should be correct one. Note it quickly. Next one. If x, y, z are non-zero real numbers, then and this is already they have given it as equals to 0. We have to find the value of this one. We'll do now. What is the question? 1 plus x, 1, 1. 1 plus y, 1 plus 2y, 1. 1 plus z, 1 plus z, 1 plus 3z. It is already given that it is also equals to 0. We have to find the value of this thing. 1 by x plus 1 by y plus 1 by z we have to find. Alright, that day I told you, we have done the question. So that day I told you, whenever we see 1, 1, 1s, no, so many ones, 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 try to make it zeros. Now what I can do is, if I subtract row 1 in row 2, that means row 2 and row 1 I am subtracting. First element will remain same, 1 plus x, 1 and 1. Okay. When you will subtract these two elements, it will become y minus of x. This will become 2y and this will become 0 because 1 minus 1 is 0. Similarly, what I can do is row 3. In row 3 also I can subtract row 1. So this 1 and 1 will get cancelled. It will become z minus x. It will only become z. It will only become 3z. Alright. Now what I can do is, one more thing I can do, I can make this term also as 0. Okay. So that way also you guys can do, or simply expand it. Because if I'll subtract here, no, this will become 0, but this will become minus 2y and this will become 2z. So that also we can do, no issues. So column 2, like column 3 minus of column 2. That also I can do. But you from here also you can expand, no issues. So 1 plus x as it is, y minus x as it is, z minus x also as it is, 1, 2y, z as it is. This will become 0. This will become minus 2y and this will become 2z. This is also equals to 0. I can take 2 common from here. Okay, I can take 2 common from here. What it will become? 1 plus x, 1 plus x, y minus of x, z minus of x. Okay, 1, 2y, z, 1, 2y, z. Either I can do this way also, or now after this I'll expand through this also. We'll get the same answer. 0 minus y and z. And I have taken 2 common. Now when product of two things are 0, that means one has to be 0. That means this term will be 0. 1 plus x, y minus of x, z minus of x, 1, 2y, z, 0 minus y, z equals to 0. Expand it and get the answer. But what I am doing is, I'll expand through here only because here we don't have to do much steps. That's why I'm doing. Okay. Let me write 1 plus x, y minus of x, z minus of x, 1, 2y, z, 1, 0 and 3z. All right, now I am expanding along one row 1. So what it will come? 6yz 6yz minus of 0 only, no problem. So if I'll multiply, this will become 3yz minus of 3xz. This, sorry, minus sign also. This I have multiplied y minus x and 3z. If I'll multiply with 0, it will become 0 only, no issues. Plus of 1. This row and this column eliminated. Yz minus of xz minus 2yz plus of 2xy equals to 0. Now what it is given? 6yz. 1 into 6yz is 6yz. This will become 6 of xyz minus of 3yz minus minus plus 3xz yz minus xz minus 2yz plus 2xy. All the terms will simplify now. All right. 6xyz, only one term is there, so I'll write it separately. This is yz term, this is yz term, this is yz term. So 6 minus 3 is 3, 3 minus 2 is 1. Okay, this is also yz term. 1 plus 1 is 2yz. It will become 2yz anyhow. 7 minus 5 is 2. Okay. This 3 minus 1 is again 2xz. This will also nothing but 2xy as it is. Take 2 common, or what I can do is I can divide full term with 1 by with 6xyz also I can do, because at the end what I want, 1 by x, 1 by y, 1 by z. Yes, I am getting the answer now. So now I am dividing full terms with 6xyz. 6xyz, 6xyz, 6xyz. Alright, and 0 is also divided by 6xyz. Both the sides I am dividing with 6xyz. So this will become 1. This will yz cancel. This will become 1 by 3. This will also become 3, and x and z will also get cancelled. Only y is left. X and y is cancelled. 2 and this is cancelled. 3 is left. So what is the left things I am writing? 1 upon 3 x plus 1 upon 3 y plus 1 upon 3 z equals to 0. Now this 1 is plus there. On the right side it will become minus. Or what I can do is I can take 1 by 3 common also. I am taking that thing common. 1 by 3 if I'll take common, 1 by x is also left, 1 by y is also left, 1 by z is also left, and this 1 will go on the right side. This 3 is divided here. On the right side it will become multiply. So this will become minus 3, and we have to find the value of this as minus will come here. So I will remove from here. So answer is 3. This only he was asking which value this will get. Answer is 3 here. Which option is getting correct? C option. This is the correct answer. C option is the correct one. So what I have done is, first simply I subtracted second row and first row, and then I subtracted row 3 and row 1 also I have subtracted. Then what I did, I simply expand it, take the terms here and there and get the answer. Note it. Let me give you the first page first. Write it quickly. The other way which I have left, that you have to do it yourself. You can simply expand from that also. Shall I move to the next page? Next slide. Quickly. You can expand this also. You will get the answer. If you want, I'll do it. No issues. But what I want is first you people try. But if you want, I'll do, no issues. I'll expand 1 plus x as it is. 2yz minus minus plus yz. Okay. Minus 1 as it is. Now yz minus of xz plus of yz minus of xy. 2yz minus minus plus, okay, minus 1 yz minus xz minus minus will become plus yz. Yes, correct. Now this is nothing but 3xyz. 3yz. 3yz is getting multiplied with 1 plus x. This is minus term. On the right side it will become plus. Yz plus yz is 2yz. And this is nothing but minus xz minus of xy. This will become what? 3yz plus 3xyz. This is, or we can take it on the left side also, no issues. So keep it on the left side only. This will become minus, this will become plus, plus equals to 0. So 2yz, now see, 3yz minus 2yz is nothing but 1yz only. So I am writing 1yz here. Okay. Plus 1yz plus xz plus xy equals to 0. Now simply divide it with 3xyz. You will get the answer. So it will become 1 by x plus 1 by y plus 1 by z, and this will become plus 1. On the right side it will become minus 1. Alright, 1 by 3 is also there, no? Now take this 1 by 3 common. Minus sign I am taking on the left side. 1 by x plus 1 by y plus 1 by z equals to 1. This 3 will go on the right side. It will, answer will come out to be 3. So anyways we can do. Note it both the ways. This is OR method. Okay. Both the methods are correct. Just simply I have expand, nothing. Here just simply I have expand along row 1. Okay. Expand along row 1. Quickly. Next. The properties of the determinant, one more property I'm telling you. Now see, this is that term only, that property only. The value of the determinant is not altered. Not altered means it will remain same. Not changed. Okay. Not changed. Altered means changed. By adding to the elements of any row the same multiples of the corresponding elements of any other row. Now same multiples. Now what he has done, A2, B2, C2, he has multiplied with M. Okay, multiplied with M. Alright, and then what he has done, he has added in row 1. That's why MB2 came here, that's why MC2 came here. Yes? Let me. Alright. And what he has done, in this row, first row he has multiplied with N. If I'll multiply first row with N, alright, and if I will add in row 3, it will become A3 plus NA1, B3 plus NB1, C3 plus NC1. So that's what he has done. Okay, so we can do like this. One row we can multiply with the same constant, and then we can add it any row, anything. Depends upon question to question whether we have to multiply any row or whether we have to multiply any column with the particular number. That depends upon questions. But maximum what happens is we generally do with the rows only. We get habituated like this only. And the question most of the time, but it is not necessary actually. I should not generalize the statement. We cannot generalize the statement. So I hope you have written this. Write it quickly. Now must remain unchanged. One row should remain unchanged. That means don't change one row or one column, you don't change. Next. These are the operations which we have applied. What we have done is one row I am changing, another row if I am multiplying with alpha, another row if I will multiply with beta. Plus minus we can do. Alright. Now similarly it can happen with any column also. Any column can be changed with alpha of column, another column, plus beta of another third column. Next, at a time at least one row remains unchanged. One time in one step at least, don't change all the 3 rows. Just change maximum 2 rows only you can change. You can change only rows or columns, not possible both at a time. Don't change both rows and both columns in the same step. No. First, if you are doing with the row, do it with the row. Then if you want to go for the column, then go for the column. Less chances of error only. This is the actually. So this is nothing but this only now. This is just an example. Alright, this is just the example. Nothing else. Do this one. Question. If delta is equals to A1, B1, C1, A2, B2, C2, A3, B3, C3, then we have to find the value of 2 of A1 plus 2, 3 of B1 plus 4 of C1. Now see, B1, C1s are here also. And here it is thrice of B1, 4 of C1. What I can do is, I can multiply this full with 3 and this column 3 with 4. Okay. Multiply this with 3, multiply this with 4 and subtract it here. So what I'm going to do is, now what I'm going to do is, in column 1, I am subtracting 3 times of column 2, 4 times of column 3. Okay, so it will become what? 2A1 plus 3B1 plus 4C1 minus 3b1 minus 4c1. Okay, 2a2 plus 3b2 plus 4c2 minus 3b2 minus 4c2. 2a3 plus 3b3 plus 4c3. We don't have to write this step. This is not necessary to write. But actually for your understanding, I'm writing. Okay. C1, C2, C3 as it is. Don't change the other things. Like this only you are multiplying and you're subtracting here. Okay. But these will remain same only, whatever the original question is. So 3b1 cancel, 4c1 cancel, 3b2 3 cancel. These terms will be cancelled. What I am left with? 2a1, 2a2, 2a3. So I'll take out 2 common. What I'll be left with? a1, a2, a3, b1, b2, b3, c1, c2, c3. Now this is nothing but delta. It is already equal to delta only. So 2 into delta. It will come out to be 2 into delta. Which is the answer? D option is the correct one. Note it. So try to do the maximum questions so that you will be able to solve it, and you will be getting an idea which rows, how to multiply, how to add, how to subtract, when to add, when to multiply. So many things. The more the questions you will do, the more the concept clarity will be there in your minds. Okay. Next, the value of the determinant this does not depend on. Now what we can do is 1 1 1 as it is, BC CA AB. I am multiplying this with AB into AC, BA into BC. This outside number I am multiplying with inside numbers CA CB. Now see, ABAC, if I'll add this, like in column 3, if I'll add column 2, what it will become? ABBC CA, ABBC CA, ABBC CA. Full it will become ABBC CA, ABBC CA, and ABBC CA. The middle column remains same. Okay. Now ABBCCA I can take common. AB plus BC plus CA I can take common. 1 1 1. Last column is also 1 1 1. Inside column is BC, CA and AB. Whenever two columns or two rows are equal, value of the determinant is equals to 0. So it does not depend upon anything. Okay, all the 4 options are correct because it is coming out to be the constant number. It does not depend upon the value of A, B, ABC. No, it does not depend. Okay. If it is coming out to be the multiple of A or B or C, then you could have written then. Note it. Next, what is the next question? X plus y, y plus z, z plus x, y plus z, z plus x, x plus y, z plus x, x plus y, and y plus z. How shall we do this? Do it. So many things are seems to be same only. What we can do is, suppose in row 1, I am adding all the elements. Row 1 plus row 2 plus row 3. What it will become? Twice of x plus twice of y plus twice of z. Similarly, it will become twice of x plus twice of y plus twice of z. Twice of x plus twice of y plus twice of z. Other things will remain same. Y plus z, z plus x, x plus y, z plus x, x plus y, y plus z. Yes, if I'll add all these numbers, x plus x, 2x, y plus y, 2y, z plus z, 2z. That's why this came. I am adding all the elements of row 1, row 2 and row 3. So I can take what I can take common. Now see, 2 I can take common from here, from there. What will be left inside? X plus y plus z, x plus y plus z, x plus y plus z. Similarly, y plus z, z plus x, z plus x, x plus y, x plus y and y plus z. Yes. Now what I can do is, in row 2, if I subtract row 1, and in row 3, I am subtracting row 1. Here z plus x is there, there z plus x is there. It will get cancelled because I am subtracting. That's why I am doing x plus y plus z as it is. This y plus z and this y plus z will get cancelled. So I am left with only minus of x. And similarly, I'll be left with minus of y. 2 is outside. X plus y plus z, x plus y plus z. Now, if I'll subtract this z plus x here, only minus y is left. If I will subtract x plus y here, only minus z is left. This x plus y will be subtracted here, minus z will be left. This y plus z will be subtracted, only minus x is left. I can take minus 1 common from here also, minus 1 common from here also. Okay, so outside it will become what? Minus 1 and 2. Inside x plus y plus z, x plus y plus z, x plus y plus z. Now x, y, y, z, z, x. Now what I can do is, in row 1, I can subtract row 2 plus row 3. Now see what? X plus y if I add, and if I subtract here, only z is left. Z. Y plus z if I subtract here, only x will left. Z plus x is only y will be left. X, y, z, y, z, x. Note till here first. Now something I am getting. Z, y, x. Okay. So we have to interchange it now. Do it quickly. till here you just note it. No, this is not the answer right now. We'll do 2 or 3 steps more and then we'll get the answer. I have to change the slide, that's why I just write till here this much. And whenever you are writing, no, side by side also just see the solution. Then you will be able to understand. All right. Now what I want is x, y, z. This I want x, y, z. I want as a first column. Okay. So I'll write it. I am interchanging column 1. Okay, column 1 I am interchanging with column 2. Column 1 and column 2 I am interchanging. So what it will become? 2 is outside. X, Y, Z. X, Y, Z. And column 1 will go inside Z, X, Y. Z, X, Y. Column 3 as it is Y, Z, X. Y, Z, X. Yes? And whenever we interchange two columns or two rows, minus sign will come. Okay. So here X, Y, Z, Z, X, Y and Y. So K value is coming out to be -2. So K value is nothing but -2. Which option is the correct one? B option is the correct. Note it quickly. That property we have done, no? If we are interchanging two rows or two columns, sign, the value of determinant, like numerical value remains same, but sign gets changed. So that's why I have done multiplied with -1. This one. Next question. Without expanding, show that this is equals to 0. Now you don't have to expand. Expand means cosecant square theta and you will just up value of the determinant. No, you don't have to do that. Directly, like you have to tell whether it is coming out to be 0 or not. Actually, it has to come out to be 0. That's what you have to show only now. So, but cot and cosecant, one identity is there. What is the identity? 1 plus cot square theta is equals to cosecant square theta. This is the property, no? Okay. What I can do is column 1, I can subtract the column 2. If I'll subtract column 2 in column 1, what it will become? Cosecant square theta minus cot square theta. This will become cot square theta minus cosecant square theta. And this will become 42 minus 40. Okay, all the elements will be subtracted. Other elements will remain same. Cot square theta, cosecant square theta and 40, 1 minus 1 and 2. Alright. Now see, this cot square theta, if I'll take it on the right side, it will become what? Cosecant square theta minus cot square theta is nothing but equals to 1. Okay, so I can apply this rule over here. This will become 1. I am writing it here. 1. This will become minus 1, and 42 minus 40 is 2. Cot square theta as it is, cosecant square theta as it is, and 40 as it is. 1 minus 1 and 2 as it is. When 2 rows and 2 columns are identical, the value of the determinant is coming out to be 0. So the answer is 0, and that's what we have to prove. So LHS equals to RHS without expanding only. Without expanding means we have to apply the properties. That's what does it mean. Note it. So for today, these many questions we have done on the basis of the properties, how to apply the properties, when to add, when to subtract, which to add, which to subtract, columns, rows, these things we have done today. Just go through with the questions once again, see the video once again, and whatever the doubt is there, get it clarified, because doubt should not be carried to the next day. Anyhow, you have to have the clarity of the concepts, then only you will be able to do more and more number of questions, and if you will do more and more number of questions, then you will be able to retain the concept. If you will be able to retain the concept, marks will be good then. Okay, so these are the things we have done, these questions we have done, all right, and the few properties we have done. So that's it for today. I hope this is clear to all of you. Okay, and one question I'm giving you, just try it, tomorrow we'll solve it. The determinant of this, you have to find the value. Just write the question quickly, and this we'll do tomorrow. B square minus AB, B minus C, BC minus AC, AB minus A square, A minus B, B square minus AB, BC minus AC, C minus A, AB minus A square. Giving you the hint from this, take B common from here, take C common from here. Okay, A common, C common, B common, A common. Take it common, and then you will be able to see. So bye guys, thank you so much. Write the question so that you can solve it.